No, I don't think. Okay, here we go. Welcome to Wawash. We want to do a series of videos, kind of giving people a background into what we are and what we do and why the art is so cool. So I figured the first one should be a 101 course, right? Because how many people really know like what's in a bottle of fragrance? So this is Fragrance 101. What is fragrance anyway?
Yeah, when you look around the furry fandom, you see so many types of art represented. You see fursuit makers, you see digital artists, you see traditional artists, you see musicians. And we realized that fragrance was an art form that was missing within the context of the furry fandom.
Yeah, I think, the other things are all things you can see, you can touch, you can feel, like, traditional art and digital art and fursuit, costuming, like design, electronics and protogens, but we did not see anybody doing fragrance, and it's a fairly complicated and fairly weird art form, but we kind of wanted to bring you in on it and show you what it is.
Yeah, so let's jump in.
So, scent is chemicals. It is chemistry and art, right? We are surrounded by millions of chemicals constantly. We are chemicals. So, and inherently, when we're talking about scent, we're talking about chemoreception, right? That's an animal's ability to detect chemicals. That is a very, very old sense. It's our, earlier than sight. It connects with our very deepest lizard brains,
Yeah, so the big thing when it comes to scent as chemicals is we're looking for something specifically called like VOCs, or volatile organic compounds, which are the smelly smells. It's all the chemicals that are floating around in the air that make you smell something.
Yeah, and there's a couple requirements for that, right? So first of all, it has to be a small molecule. We're not talking about big proteins or weird stuff like that. We're talking about stuff that can literally fly out of a flower or will evaporate and will eventually reach your nose, right? Because these things have to get to the nose. They have to get up inside your nose in order for you to detect them. So let's talk a little bit about where those things come from, right? Flowers are a big one, right? You walk through a field and it seems to like jump out of the field. You could smell them from really far away, and there's good reason for that. Like, plants are trying to attract pollinators. Evolution has given them that ability, and that's why we can smell these things. That's why they emit them, right? They're trying to attract bugs. They're looking for like beetles or
flies.
Even hummingbirds and stuff. So they're looking to attract something, and they're trying to get something out of this. But we've evolved at the same time with those things, and now we have sensors, receptor sites to pick up those things, and we as humans find them pretty too. So they've kind of developed a second purpose, right? And if you think about it too, there's also the artificial selection aspect of it, where it's like humans like smells, so sometimes we breed things to be extra smelly, right?
Exactly. So another good example of this is fruit, right? Food really is, your taste is a lot of it is smell. You have your core, 6 tastes that there are?
Yep. Supposed to be 6 tastes.
Supposed to be 6, yeah. But everything else you're tasting is actually smell. So when you bite into a chocolate bar and you love that chocolatey goodness, most of what you are tasting is the smell of chocolate.
Yeah, a lot of that's not taste. It's
right.
Smell. It's all happening in your nose. It's being volatilized, in your mouth and brought up to your nose.
So fruit, it's delicious. We love it. It's super sweet. It's super tasty. And fruit, the purpose of those smells and why it's so delectable is it wants to attract critters.
It wants you to eat it.
Yeah, it wants things to come and pick its berries and eat it and fall out of its mouth.
Yes, and poop out the seeds, preferably somewhere where it will grow, right?
Exactly.
So that's another evolutionary mechanism. That's why nature did these things, and that's why humans like the taste of fruit.
And a good third example of this is in animals. Lots of animals, you go down into even insects, you have pheromones being used for ways of communication, socializing, and, cueing for, hey, danger, danger, there's a bear at the beehive.
Yeah, like bees will definitely put out warning signals letting the workers know that what's going on. You'll have things like foxes that are laying down signals to define territory, and dogs, and I mean even red pandas, right? We do this thing with our paws where we go like this on the ground, and there's a clear fluid that's secreted from the paws. It contains chemical messengers to other red pandas, right? And I think the other thing too is like that's really neat is how, you know, when you walk through the field of flowers, you can smell that stuff from hundreds of feet away if the wind catches it right. It's trying to attract something, right? It's trying to get its signal, you know, through a megaphone, loud and proud to all the insects. Hey, I'm over here. Come look at me. Fruit, you know, it's internal. It's mostly volatilized in the mouth. It wants the thing to learn what it looks like, learn what it tastes like, and then eat a lot of it. Where animals, on the other hand, like, you don't really smell those things until you get close to them, right? They're heavier molecules. They have less vapor pressure. They have less volatility. They're less likely to evaporate. So those things, they're mostly designed so animals can follow trails, right? And they can smell around. And they can be like, hey, this thing was here. Like, very different intents behind this stuff, but all chemical signaling and all detected with chemoreceptors. I mean, humans don't have pheromones, right? We don't have the ability to detect pheromones. In us, that's a vestigial organ, right? It's still there, but animals specifically are looking for these things.
Yeah, instead we have 400 unique receptor sites for scent.
And sensitivity to over 1 trillion scents.
Yeah, and that's pretty neat. I mean, that's the beauty of fragrance, is that there's so much you can do with it that it's practically an infinite art form, you know? So, how does fragrance work?
Well, we wish we knew. We wish scientists really knew. There's a lot of speculation. There's not really a conclusive answer to this, right? I mean, we've studied the olfactory system a lot, right? And you can see kind of up in here, you have this bulb that'll transmit signals into the brain, right? But how does, you know, this part right here, the olfactory organ, work? Well, there's some hypotheses on this, right? We know that these things enter the nose and diffuse through that membrane and send out an electrical signal to the brain to tell the brain something or give it a piece of information. But we're not really sure if that works like normal, you know, neurology, right? Does it fit into is it a key that fits into a lock and the exact shape sends the signal? Or is it something different, right? There's a researcher by the name of Luca Turin who hypothesized that it's a vibrational thing, and the chemicals work a little bit like our GCMS behind me, which is probably all the noise you're hearing. But it's one of these things where he hypothesized that maybe that chemical fits in there, and the resonance of it also has something to do with it. Both are disputed. There's no conclusive answers, but it's very possibly a combination of the two.
Right. And the really interesting thing about scent is it is one of the most nostalgia-inducing scents. So it is the olfactory cortex is actually located right next to the amygdala and the hippocampus, which is where your emotional responses are driven from, as well as where your memories are written and recalled from. Which is why, you know, when you smell something, maybe you smell a flower and it's like, oh man, that smells exactly like my grandmother's house when I was 3 years old. You know, we're pretty much hardwired for scent to be directly correlated with strong emotional ties and memory.
Yeah, like everything else flows through the thalamus, right? But scent does not. It goes directly to the limbic system. And it's like, that is like a primordial, like very early part of the brain that's very implicated in our feelings, our moods, our sexual behavior, our memory. Like, you know, it kind of bypasses thought and goes directly to like, oh wow, like this is something that I very deeply connect with. And I think it's very cool that we're bringing that, you know, into the furry fandom, because it's a very strange art form and you don't see a lot of it done.
Yeah, and one of our favorite little kind of games to play sometimes is we have a number of chemicals over here in this fridge back here that, you know, you open it, and if you know what you're like thinking about while you smell it, you go, oh man, this smells exactly like, you know, a rose, or this smells exactly like a banana. But If you don't know that already in your head and you just crack it open and have someone take a whiff, it's really fun to watch those cogs try to turn as they try to make that correlation. It's like, oh, I know exactly what this is. It's triggering this immediate memory response in me. But what is it? You know?
Yeah, it's fun because you can't easily play. You can remember scents, and you're like, oh god, I know what it is. It's like when you, it's like the thing. I think I saw this on Chef's Table, right, where they cut an ingredient and they put it under the chef's nose.
Oh yeah.
And it's so hard. They're a professional trained chef, like, you know, and it's so hard for them to guess what it is. But they know what it is, but putting a word to it is hard because
Exactly.
it's bypassing that part of the brain. I love this quote from Andy Warhol. I had to include it. I think he's, you know, he had this, he's a kind of a polymath when it comes to art, but he also very much respected scent, even though it wasn't an art medium he worked in. He had there was a theater in New York that he was very fond of, and he has a quote somewhere where he describes, like, hey, if they took pictures, what good are the pictures gonna do me, because I can never smell it anymore, right? He says, of the five senses, smell has the closest thing to the full power of the past. Smell really is transporting. Seeing, hearing, touching, tasting are not just as powerful as smelling, if you want your whole being to go back for a second to something. And I think that's what we're trying to do. We're trying to connect with people on a level where, you know, a fursuit spray itself just won't get, right? We're trying to bring scent as an art medium into the fandom. So, you know, you can make it part of your persona, make it part of your character, and we're trying to give you something that you really connect with. Something made by furries for furry noses. So, spoiler aside right there, nature is one giant chemical factory. That's the moral of the story, right? We are chemicals. We are surrounded by chemicals. Everything is made out of chemicals. So what is Wawash doing, right? And what is fragrance? And what is fragrance design and fragrance art? What is perfumery, right? What we're doing is we're taking individual pieces of these things, these flowers, you know, these musks, all of this stuff, and we're combining it to make a new art form, right? So let's talk about how many chemicals are in certain things. And we're not really talking about how many chemicals are in the lime. We're talking about how many chemicals are in the lime that are volatile. So when you slice a lime and you put it on the counter, how many things are floating out of that lime and into the air around you and can be detected, probably by your nose, right? So, and there's a lot. Like, you walk by that flower, it could be giving you hundreds and hundreds of chemicals, but a lime itself has, you know, slightly more than 60 compounds that we can detect and we can analyze. That's 60 different things that sum together to make in your mind what a lime is.
And a lavender is going to have just over 100 compounds.
Getting a little bit more complex, right? Vanilla, you'd think it would be something very simple. You think vanilla is like, you know, is fairly vanilla. It's not. There's a reason humans go to great lengths to get vanilla pods. You know, they will individually hand pollinate flowers. The vanilla itself, while, you know, vanillin, you know, which we'll talk about in a second, is one of the main things we smell. Vanilla is really complex. It's over 200 compounds in a bean.
Yeah, and the last one is that we have on our examples here is a rose. You know, a rose is far more complicated than would initially seem. You know, there's over 400 volatile compounds in a rose that make up its scent. Now, when you actually look at these, each one of these, there's 3 to 5 things in it that are going to make up like 95% of its fragrance, right? So you can take those 3 or 5 things in those quantities and present it to someone and be like, wow, there's a rose smell.
A rough sketch of it, right?
Exactly.
And yeah, they say a rose by any other name would smell as sweet, but if you want to know what, you know, the smell of a rose is, you'd have to list out over 400 chemicals and their quantities, and that is the smell of a rose. That's nature's sheet music for the rose.
Yeah, and when we're trying to come up with a fragrance, right, and we're like, oh, well, we want this element of it to smell rose-like, you know, or we just want, you know, if we really want it to smell like a rose, we'll take those big 5 ingredients that make up the majority of a rose, and we'll use those. But say we just want a hint of rosiness in something, well, maybe we'll pick out some of the more interesting, complex terpenes in there that make up the bulk of those 400, and we'll use those. Or maybe there's one specific weird, you know, special effecty chemical that we want to pull out of it that we want to use. So
Right.
we parse through all 400 of those chemicals to kind of pick and choose to decide what's our goal when we're creating a fragrance.
Yeah, you may not want to use a full rose extract or oil or something like that. You may want just one little component of it, right? We'll sort through, and hey, maybe there's this one compound that's really interesting. You don't have to use the whole thing. Sometimes we'll slip little fragments of what nature has already provided into a formula.
So we're gonna just like run through a couple of examples of some of these things and what some of their major fragrance components are. But first, this is just to show you how many chemicals can be present in a plant. This is a GCMS spectrograph of spectrogram, thank you, of California bay laurel.
We picked this up in California while we were there for a convention last year, and we're like, hey, this smells really nice, so we're gonna bring it home. It smells really complex, and it turns out that it was. So what you're looking at is a chart that was spit out by our instrument, and we will get into exactly how that works later in a different video. We're hoping to do a lot more of these. But you can see every one of these peaks, that's an individual chemical, and the area underneath the peak is how much of it is there. So you can see just how much. Like, you smell a California bay laurel leaf and it smells to you like one thing, but it's actually not. It's hundreds of things that are mixing, to make it, to give it the sum of it of what you're smelling.
So now we're back to that rose. So what are some of the big things that make what makes a rose a rose?
Well, to the average person, right, if I mix these three compounds in the right ratios and I put it under your nose, you're going to immediately say rose, right? I don't need all 400 to tell the story. I can give you something that will trigger that memory in your mind of a rose with three compounds.
And so our first one here is phenylethyl alcohol, also called PEA in the fragrance world sometimes.
This stuff is everywhere. This stuff is in so many flowers. It's in so many formulas. It's really light and universal and very easy to work with, and kind of has this general floral scent. Mm-hmm. Not the full picture, but it's part of the rose.
And PEA is the big thing that you find in rose water. It's a big part of what gives it that rosy flavor in the rose water.
Yeah, and the interesting thing is, how you can stash a bottle of rose water in your fridge for 6 months or a year and it still is just fine and it smells like rose water? That stuff is a preservative, and it comes from the rose itself. They don't have to add that. It just is in there.
So the next thing is geraniol.
I don't know how to describe this one. It's very sweet. It's floral as well, but it's more candy floral.
Yeah, it's a sweeter floral. It's predominantly found in roses, geraniums, lavender,
baby
powders. But yeah, it's again similar to phenylethyl alcohol. It's kind of a pretty universal staple ingredient in the fragrance industry. And the third one is citronellol.
Citronellol does in fact smell like the bug spray and bug repelling candles, and it is the same smell that you're smelling with those. But it's interesting because when it's blended with these other two things, it no longer smells like that. It becomes something new. It becomes part of the rose.
So our next thing is grass.
So when your dad used to mow the grass, and he maybe had that bag on the back of the lawnmower that collected the grass clippings, and when you'd open that, you'd have a smell that came out that was very, very potent. That chemical is cis-3-hexanal, right? That is basically the smell, like 90% of cut grass smell. Every single person that I put that under there would be like,
grass.
Immediate thoughts of weed whacking.
Yeah. Yeah, and this, at least in the fragrance and perfumery world, that type of aroma class, we would say it smells green. It smells green like grass. It has that kind of grassy odor to it. And there's a whole bunch of chemicals that have that green element to it, but cis-3-hexanal really is that truly just like fresh cut grass smell.
Green banana. So when you leave bananas on your counter, and maybe you are hungry for a banana and you cut into one a little bit too early, it has a very distinct odor. It's like almost papery, a little bit waxy, a little bit astringent, and it just smells different from a yellow banana. You can I imagine that you can smell this in your mind, right? The chemical that does this is trans-2-hexanal. All of these things are really neat little building blocks, but the two that we've showed you so far, and the third one coming up, these are like almost all of you will get this impression from this one chemical. It's like, oh, immediately green banana.
Yeah, it's really actually quite neat how, despite how complex and the true fragrance of something is, that 1 or 3 or 5 molecules, are enough to tell that story. It's really cool. So, as we mentioned earlier, vanilla.
Yes, so vanilla, the main compound in it is vanillin, right? And there's also ethyl vanillin, there's also hexanal, all these things like sum together.
Ethyl maltol, yeah.
All of these things sum together to be vanilla, but if I put that under your nose, you will immediately say vanilla.
Yeah. So, there are thousands, and we say thousands, but really it's tens of thousands more fragrance molecules out there.
Yep. Some of them come from nature, some of them don't. Some of them are extracted from nature. So sometimes it is cheaper and easier to get the chemicals from nature itself. So in the case of like something like geraniol, right, or linalool, those are produced by flowers all over the place. It is cheap and easy to fractionally distill or extract or get those things from nature.
Yeah, and sometimes, we can't use what's found in nature because maybe it's not ethical to take it from nature. Maybe it's a musk that's being produced by an animal, or maybe it's just not commercially viable to get it from nature. Maybe you're distilling down 100 pounds of a plant to get 1 droplet of this, So sometimes we have to synthesize these.
Yep, and just because it's synthetic does not mean it's any different. It is the same exact chemical as in nature, only more pure and easy to work with, and more cost-effective and better for the environment rather than growing, hundreds of pounds of something to extract one little thing.
And some of the things we work with are entirely synthetic.
Yeah, so there's a lot of examples of what we call rational chemistry, where someone will look at something and be like, oh, we can make variations of this, right? So there are things that don't exist in nature that are really neat special effects that now we can make with the power of chemistry. Sometimes there are versions of things versions of chemicals in plants that we love the smell of, but they're so toxic that you cannot use them in fragrance, right? So the thing is, like, just because something says or something is natural does not make it safe, right? So a good example is eucalyptus oil. Eucalyptus oil is deadly to a human being, in less than 1 cc of fluid, right? Mm-hmm. So in that case, you're going to take what you want, and you're going to not use the natural, and you're going to synthetically reproduce a version that's safer for people's daily consumption, right? So not only does this give us a chance to create very interesting special effects, it gives us a chance to work within safety margins that are appropriate for somebody's, to use this on a daily basis.
Yeah, it allows us to bring those fragrances that we love that maybe our body doesn't love, that ways around that so that we can still enjoy those smells. And lastly, there's a lot of various ways to get mixtures of fragrance molecules. There's essential oils, there's distillates, there's extractions, and so many more methods. And each one gives you a different snapshot of the plant.
Yeah, so I think there's a lot of cases, and there's a lot of products that you find from us too, where you will find a natural essential oil from the plant. When we want the complete full picture, we want it to, like, let's say we have Sheba Sherb is a great example.
Yeah.
We have real Sri Lankan lime distillate, and we have what's our lemon? It's Italian.
It's sfumatris, which is a specialty method of cold pressing the lemon rinds to get their natural oils out of them. But the lemon itself is sourced from Calabria, Italy.
And that was really important to us because we want the full picture of lemon and lime in that, right? And if you just include the things that have a commercial synthesis route that you can actually make, you won't get the full picture of the lemon or lime, right? So we went out of our way to find the perfect smelling lemon and lime. Those are like, it's like growing grapes for wine. It's one of those things where it matters where it's grown, right? And you're going to get compounds in there that you can't produce synthetically. So it's important to us to, where it's applicable, go to directly to nature and take a distillate from a plant.
Yeah, I think for Sheepish Herb, we auditioned something like 4 different lime oils and like 7 lemon oils.
Yep.
2 of which were not even lemon oils, but verbena lemon oils.
Yep.
So yeah, it's really interesting how you can take, even if it's the same lemon from the same region, just the method of extraction makes such a big difference, you know?
Yeah, and there's also variations in distillation, right? Are you taking... So, normally you're crushing a whole bunch of lemons and you're boiling them and you're taking just the oil that's produced by that. But what temperature are you boiling them at, right? Do you want the stuff that is really volatile, like the flowers put off? Or do you want the stuff that's heavy, like an animal would leave, that would be left behind with a lemon that's dried or maybe left on a counter for a few hours, right? What do you want to add to the creative vision, to the scent itself?
Yeah. So jumping into a couple examples of some of the things we mentioned here about the synthetics, if you stayed at the Westin during Anthocon, you have most definitely smelled this because everyone was walking around after washing with it. Well, hopefully washing with it.
For 3 days, we smelled this compound, and it's one of those things that they put in there because it is very cheap, right? And a lot of times these big fragrance companies, are making this stuff for hotels. Like, what's the bottom line for them? They're looking at cost. They want to know what the cheapest they can produce a 55-gallon drum of this is, where people will be like, oh, that smells nice, right?
And in this case, that compound is galaxolide.
Right, and that's a synthetic musk.
Yeah.
So essentially when we talk about, the panda going like this with its paws, leaving something on the ground, or the fox who's marking, right? This is galaxolide. And this is why you smelled it on every single person in that convention center for 3 days, because they washed with it. Anybody who stayed at the Westin, right? And as a perfumer, I can smell that stuff from a mile away because it has become a cliche in fragrance, right? That ISOE super, all of this stuff, it's like when you walk through a Target, the fragrance center, and it's like you walk, pass the men's fragrance,
right?
Like,
you smell all the Axe and all the what is it, the Old Spice and everything, and it's so much of it is these big synthetic musks, because that's just what they has become the standard of masculine fragrances.
Right, yeah, and the funny thing to me, too, is like, how we talked about how there's that disconnect between the language center of the brain and the actual experience part of the brain. Well, they're telling you that galaxolide smells like white tea. It does not smell like white tea to me. I don't know, if you smelled white tea next to this stuff, I don't know that there's any connection whatsoever, but it's kind of like this chemical tofu that people use. But perfumers' noses are very sensitive to this stuff, and it's like you could spot it from a mile away.
Yeah, and on the topic of tea, so the next chemical we're going to talk about is dihydroactinodiolide. And this is actually something that is found in black tea, and is actually something we sourced for use in gray muzzle.
Yes, and it's one of those things that's found in very few places in nature, right? It's fairly exotic, and it's very, you're not going to be able to extract this from a fox in 2025. It also is produced in fire ants. I couldn't find a good picture of a fire ant. I'm trying to the Free Vector website only had a bunch of crappy AI stuff and a very few other stuff. But we went to great expense to get this stuff for gray muzzle because every analysis we did on black tea, it shows up. And it smells really neat, and it has it's a big component of what tea smells like to me. It's that kind of very bright, tea aspect of it. But it's present in very few places in nature, probably less than 15.
Less than 15 different places in nature. The main ones are the anal scent gland of the red fox, and are as a chemical signaling of fire ants, as well as found in black tea. And so it's a really unique chemical, and it would be impossible to get this, from nature, and in a lot of ways unethical to get this from nature.
Yeah,
so we synthesize it.
Yeah, and the synthesis is really challenging. I imagine the yield is not very high because the cost of this is something near $3,600 a kilo versus galaxolide, which is $5 or $6. So, it's 2 orders of magnitude more expensive. But, I mean, you're using it in small quantities, and, as a small company, we don't necessarily have to look at that cost, because fragrance in general, they're trying to meet a price point. They're just trying to meet bare minimum, right? But we're trying to make a piece of art, so we don't necessarily mind if we need, 10 or 15 grams of this in a batch of fragrance.
So fragrance itself and the crafting of fragrance is more in common with music and making music than it is something like painting. We work in a time domain with fragrance. When you smell something, you're not just smelling one thing. Like we mentioned, there's hundreds of chemicals in some cases that are making up that smell, and all of them last for different amounts of time.
Yeah, so basically, what we talked about with volatility, right? That's like the flower versus the fox. How likely is it to vaporize? How likely is it to go into the air? Well, if it's more likely to evaporate, and more likely to head out into the air, it's not going to last as long, right? So it's an important part of fragrance design that we think about, what's going to last this period of time, right? The end goal is to have a fragrance that lasts for 6 or 8 hours. But that doesn't mean that everything has to last that long. We're telling a story, right?
Exactly.
So we start with the introduction, and then we move to the, the meat and potatoes of it, and finally the conclusion that'll last for, that'll be in the end. What are you left with after everything else is gone? Any of our fragrances, you can spray on a scent strip, and I encourage you to do this with anything you bought from us. Spray it on a paper towel, spray it on a plushie, anything. Smell it immediately. Come back 2 hours later and smell it. It will smell different. Come back 4 hours later, it will smell different. Mm-hmm. And at the end of the day, it's going to smell like a new thing. We're telling a story. It's more like music, right? So all of these chemicals, they have a different vapor pressure. That's how likely they are to move off whatever you sprayed them on and out into the air, right? That's analogy. The analogy to that is time in music, right? And every chemical has a different volume. That's analogous to how sensitive is our nose to it.
Yeah, there are chemicals that we're sensitive to the parts per trillion of. A good example of this is
Jasmine.
I was actually going to say sodalone. That's a funny story too.
Yeah, sodalone is definitely a neat story, right? So, exact details of this, I don't remember. You have to Google it, but there was a plant in New Jersey making maple syrup, fake maple syrup, not the Canadian kind. And the chemical that they use to make fake maple syrup is called sodalone. That's what gives it that maple smell, right? I believe it's found in maple sap as well. Not sure, but it might be synthetic.
If it's fully synthetic or not.
But humans are incredibly sensitive to this stuff. And for large periods of the operation of this plant, it was wafting over Manhattan. And people were calling the EPA, reporting a mysterious smell of maple syrup.
Yeah, it went on for something like 2 or 3 years.
Yeah, it was a long time.
That they were only off-gassing trace amounts of this, as just a part of byproduct of their production. And it was, humans are so sensitive of it that they were able to smell it, all the way in New York City.
Yeah, and the EPA was called in, and was doing air sampling and stuff until they finally determined that, where it was coming from. But it's a very, very potent compound. And that's like volume, right? It's like you may have a lot of this chemical in the air, but if you're not sensitive to it, you're going to smell very little. Mm-hmm. But there are certain things that we use in very, very tiny amounts because humans are so sensitive to. And that's basically volume, how loud you have it in the mix in music.
And sometimes, there are things that we're, really sensitive to that you put in there at, a fraction of a percent. It's 0.001% of your formula. And sometimes you really are making an artistic statement by making that a focus of it. And you're, overdosing that beyond what it would, seem natural to smell as, so that it becomes a prominent part of your fragrance. You know, that's one of the tools you use as, you know, a perfumer or someone working on fragrance, is the ability to make those artistic decisions about whether or not you want this to just kind of, you know, blend into the mix and be a supporting role, or whether you want it to be the lead vocalist.
Yeah, and I think going back to that mass spectrum we showed you before, that plant we collected in California, some of those biggest peaks you see, those are not the most important things that you're smelling. Some of the most important things are the smallest little things you see.
Yeah. And this is part of why it takes 6 to 8 months for us to create each fragrance. We work on multiple in tandem, you know, we'll work on 2 or 3 different fragrances at a time, but it takes quite some time, because there's, you know, there's the artistry of it, there's all of those decision makings of trying to tell your story, but you're also limited by the chemistry of it and the physics of it. There's, you know, you are tied to the constraints of this vapor pressure and this sensitivity of the nose.
Yeah, the human nose is not necessarily like music in the way that, you know, music, you can listen to the same song a bunch. I mean, your ears do get fatigued, they do get tired, but the nose gets tired in a different way. Mm-hmm. So if you smell one of these compounds right from the bottle, right, they're not meant to be experienced like that. The human nose is, or any animal nose, is very good at shutting down a specific smell. And why is this, right? Because we have millions of chemicals around us all the time. Scent is part of what keeps us alive, right? It's part of what tells us, hey, there's a predator over here, or hey, there's danger, or hey, I shouldn't touch this. It's like, you know, insects being brightly colored, you know, to keep you from eating them. It's like, hey, I shouldn't touch this. But it's important that we sift through that noise of what's going on, right? So if you overexpose the nose to one thing, now it's desensitized to that for a certain amount of time.
Yeah, when we're working and making new blends and trying new things of fragrance, you know, we have to take breaks constantly, because we can't just sit there and blend and blend and blend and blend, because your nose really does get worn out. You know, you develop anosmia pretty quickly to these things.
Yeah, and you can only really do 3, maybe 4 iterations of fragrance in a day before you're spinning your wheels. You know, so that's one of the reasons it takes so long. It's kind of an art form that part of the charm of it is how long it takes and how much time in between variations, and that forces you to slow down and think.
And so to finish this off, to kind of cap everything up, what makes us different? You know, what is the difference between the artistic fragrance that we've been talking about this video and that we make versus functional fragrances like, you know, for example, fursuit sprays or Febreze?
Yeah, we have a lot of people come up to the table, you know, at conventions, and they're looking for a fursuit spray. And the first thing we have to tell them is, hey, we're not really a fursuit spray, right? We're not a functional fragrance. Functional fragrance can take a lot of forms. It could simply mean something that will disinfect, like fursuit spray. It could mean something like Febreze, where it cancels out odor, right, by trapping it. It could mean a company that has a product that kind of smells bad and they kind of want to cover the smell. Mm-hmm. Now, the whole point, like Febreze itself works by being a cyclic molecule of dextrin, right? And we know dextrin as a simple sugar, right? And it's a molecule that will surround the odor that's offending you and kind of trap it, right? And we talked about the size of those molecules influencing the way that they take flight in the air and are able to enter our nose. So the thing about cyclodextrin is now that molecule is really heavy and it can't get off the ground and make it to your nose. So is it actually getting rid of odors? No, but it's making the odors very, very imperceptible. Like, you won't be able to smell them. And it's very good at that. Cyclodextrin is insanely effective. There's a really good story behind Febreze in the beginning where it just was not selling.
Oh,
and,
yeah.
Yeah, and they could not figure out why until they did some research here, and they realized that, like we said, people's noses adapt to stuff, and then they cannot smell it anymore. And people's homes are like that, too.
Yes.
People's homes have this particular smell.
Right, yeah. If you spend all day in your house, you know, it just becomes kind of this neutral background, right? You don't particularly smell your house all the time, but say you've been gone on a work trip for a week or gone to a convention for a weekend, and you come back home and you just get hit with that smell of, the house. I know for me, it's one of my favorite experiences when we come back from a con of like walking back into the house and being like, this is home that I'm smelling. But, after a few hours of sitting in it, you become anosmic, your nose, desensitizes to it, and it just becomes a part of your surrounding.
Yeah, so initially, Febreze was just cyclodextrin.
Yeah.
So they would sell it to people would spray it, and they wouldn't smell a difference because it's removing something that they already have filtered out by their brain. And then they realized they have to add functional fragrance. Mm-hmm. So the functional fragrance was there to make you smell a fresh thing, to make you want to keep buying it and using it. And it worked.
Yeah.
The product did really well, and it became, Febreze. We all know Febreze, right? So, fursuit spray, on the other hand, fursuit spray is 70% isopropyl alcohol and fragrance, right?
Yeah.
70% isopropyl alcohol has a very low vapor pressure, and that's why we use it. We use it because in order for something to sanitize or kill bacteria, isopropyl alcohol is really good at that. It has to be at 70% because otherwise it'll evaporate too fast.
Right, yeah. What is the actual sanitizing effect of it is the strength of the alcohol as well as the amount of time it's left on the surface. So 70% is kind of the perfect balance where it will stay on a surface long enough as it evaporates, but is also at a high enough concentration to actually, kill off bacteria and such. So if you were to use, 99%, it wouldn't really be effective as a disinfectant. And the goal of fursuit spray really is to be a disinfectant. The fragrance is there, again, as a functional fragrance, so it doesn't just smell like a cloud of booze. But, they'll put 2 to 3% in a fursuit spray of fragrance so that it smells pleasant while it's doing its thing.
Yeah, and I think the thing is, like, it's very functional. It does what its job is, but at the end of the day, there's a drawback, right? There's a tax to that. There's a price to be paid for using isopropyl alcohol because isopropyl alcohol, A, doesn't smell very good. B, because it's taking so long to evaporate, those top notes that we were talking about before, the flower scent, not the fox scent, those are gone by the time the alcohol's gone. So you're not getting this full picture of the fragrance, right? And since we're making art, right, fragrance is our art form, we don't necessarily care that it's not functional. We want to play with your brain a little bit. It's important for us that it smells great in the beginning and continues to smell great. So Wawash uses ethyl alcohol the same way fine fragrance does.
Yeah, specifically, we like to use 200 proof, undenatured, food grade, that's kosher, halal, and all the different things. And we use that because we truly do want the fragrance to be the star of it and the forefront of it. We put so much love and labor into each one of these scents that we don't want it to be ruined by the first thing you spray, you smell alcohol.
Yeah, and ethyl alcohol is an extremely high vapor pressure. I'm sure at any given point, any one of you have gotten alcohol in your hands. You know how it feels cold? It's because its vapor pressure is so high that it's evaporating very quickly, and with it, it's carrying away your heat. So what we want is you to spray one spray across your bed, one spray across your fursuit, or your plushie, and the alcohol leaves very, very quickly, leaving only behind our art. Yeah. So I know it is inconvenient that it won't sanitize, right? But there is an alternative. You could use a more traditional fursuit spray. You could use a 70% isopropyl alcohol to pre-sanitize, and then use Wawash as a finishing spray. And I think that sends our message a little bit better. That'll carry our artistic statement.
Yeah, and really, when you're just kind of jumping back to the functional fragrance element of it real quick, when you're developing fragrance, a little bit more behind the scenes when we're thinking about building a fragrance, we're developing the fragrance for that art form. We're specifically developing fragrance as an art medium to be smelled as an art medium. It is the point. The smell is the point. Whereas when you're building a scent for something like Febreze, or you're building a scent for a laundry detergent or something else, you're going to pick different chemicals as a result because you want the smell to stay on there for a long time and stick around for a long time. You're going to use more of those like fox, musk scents and stuff like that because you don't want it to just get washed away. Say for a laundry detergent, you're not going to put a bunch of top notes that only last for 30 minutes because by the time the wash cycle's done, they're gone.
Right, you're not going to use molecules that are very heat sensitive for a laundry detergent, because as soon as people put their stuff in the dryer, the scent's going to be gone, right? And that's why, the Westin hotel stuff did very, it carries very well, because that chemical survives through a shower. It's not washed away necessarily. So that from the perspective of functional fragrance, you're working with a very limited palette.
Yes.
It changes the odor. And with a fine fragrance or a perfume, our stuff doesn't smell perfumey, especially when you consider like nostalgia and food or what we specialize in, but it has that complexity.
Yeah.
And it's designed to just say something.
Yeah. And that looks like the end of our slideshow here.
Thanks. So thanks for joining us. We're going to do more of these. The next one will be kind of showing apart how we do rip apart a flower and determine what's inside. But we kind of wanted to give you the Fragrance 101. So keep updated on our YouTube, and we'll hopefully have some more for you.
Yeah, we've got a couple ideas. We wanted to get one on, how this bad girl works, and how we analyze her data. Probably do another in-depth, real deep dive into the chemistry behind fragrance. Maybe walk you through us building a fragrance. But yeah, we would we hope you enjoyed this video and come back for more, or don't. Your choice.
Till next time, Wawash signing out. Thank you.